Welcome to the Terminology Leading Practice stream at SNOMED CT Expo 2023. My name is Liara Tatina. I'm the Customer Relations Executive for Asia Pacific and Global Education Lead for SNOMED International. I will be moderating the session. All questions will be answered at the conclusion of presentation. Online attendees, please use the Q&A button to type your questions to the presenter. On-site attendees, please use the microphone provided in the room. I'm now pleased to introduce Orsolya Bali from B2I Healthcare, who will be presenting enumerated code list reduction to smart intentional reference sets. Orsolya, please go ahead.
Thank you, Liara. Hi, everyone. Thank you for coming. My name is Orsolya Bali. I'm representing B2I Healthcare from Budapest, Hungary. Before we get started with this presentation, I would really like to acknowledge all the hard work that was done by our B2I team, because what I'm presenting is not actually just my work, it's their collaborative effort, including András Péteri, one of our developers who's not here today. So András, if you're listening, great job. And everything that we built was based on a previous work by Jeremy Rogers at NHS England. He implemented a tool that's called the Data Migration Workbench, and he really paved the path for this work as well. So just to set things right, the topic for today is enumerated code list reduction to smart intentional value sets. This complicated title really translates to transforming simple type ref sets to query type ref sets. So that's what we're going to talk about. I always puzzled a little bit as to how far I should go back when trying to introduce these topics. And I don't think I really need to discuss what a reference set is. Looking at the audience, you seem to have an idea of what a reference set is. But it's still, I believe, is important to recap on different ways that you can use to define a list of things or sets of things. Now, for example, if you look at that picture, you could describe it by starting to say that you see a panda and an orca and a penguin and a zebra and so on and so on. Or you could just say that in this picture, you see a bunch of animals that are black and white in color. Both definitions result in the same set, but they're different, conceptually very different ways of describing this set. The first is called an extensional definition. In SNOMED word, that's a simple type reference set. That's an enumerated list of concepts when you're listing the concepts one by one. It is a great way to collect different concepts for different domains, but when it grows in size, it can be tricky to maintain. And I happen to know about a lot of these large simple type ref sets that are difficult to maintain. We'll discuss that later. The other type of definition is the intentional definition. That's when you create a query to define a your set. You pick a characteristic that each member share, for example, a relationship, or for this case, it's the color of being black and white, and you use that to describe the contents of your set. That's something that's called query type reference set in SNOMED City. There is a language that's called the expression constraint language that supports building these queries. It can use not only the semantics of the concepts, like the relationships, but even some properties and some metadata of these concepts. The reason why we like query type ref sets, and the reason why we think that's more future-proof than the simple type ref sets, is that they're easier to maintain on the long run. If there is a new version of SNOMED City, and in every month there is a new version of SNOMED City with new content, you need to make sure that all the references that you built on your previous version is updated or are updated to this new version. You need to review the contents. You need to decide whether there were some changes in the modeling, whether there are some inclusions that you need to apply. And if it's a query, this process can be automated. It can be streamlined to be more effective. And since you need to do that quite frequently, it's a good thing to make it more effective. There will be another presentation tomorrow by Mark that discusses the ref set upgrades in more details. So I'm not going to focus on that part. What I would like to discuss is how you can move from your simple typesets to query typesets to enable all this automation and streamlining that we're dreaming about. The problem statement is really what I just said already. So there are large collections of reference sets. Sometimes they are from legacy code lists that were mapped to SNOMED City. Now there's SNOMED City ref sets, and they require maintenance. They require frequent maintenance when it's a national release center. We're working with the UK, and we use two of their large ref set collections. One has 200, the other has over 800 ref sets. The total member count is over 100,000. So these are really big reference sets they need to review periodically. It's a huge effort from their side. And they already did the first steps to make this easier by implementing a method in the data migration workbench that transformed some of the simple lists to queries. These queries are still very simple in their structure because they only describe hierarchies or sub-hierarchies, but it's a step to the right direction because they're already queries that can be re-executed whenever a new version of the terminology comes along, or you can even test how they work on other edition of SNOMED City. So what we did is, building on this set of algorithms from the data migration workbench, we implemented these ourselves as well, with careful guidance from NHS England. We extended these algorithms a little bit, so it's not just hierarchical definitions that we build, but also semantic refinements. So these resulting expression constraint language expressions are now more complex and utilizing more of the ECL functionalities. And as a last step, we made it available as an online service, which means that you have a process that you can use to get from a list of codes to an RF2 release of query type ref sets. You just need to import a spreadsheet with your code list. It can really be that simple, so it doesn't even have to be an RF2. It can be any spreadsheet that contains SNOMED City concepts. You need to optimize this and SNOMEDize it in a way that the necessary reference set identifier concepts are created in particular modules under particular namespaces. So it is all ready to be bundled as an RF2 release, and then it can be published via an API or by downloading files. A little bit about the algorithms that we use. I'm not going to go into very deep details in these, but just on a very high level how they work. The starting set is always a set of concepts. It can be a result of a previous query, or it can be just a simple reference set. We look at these concepts and start building inclusion criteria. First, look at relationship refinements and see whether there are concepts that share the same relationship type and relationship value, bundle them together under a query. Then there is an iterative process that collects hierarchical refinements. And since there are always some concepts that don't just fit under any of these queries, they're added explicitly under them. And at the very end, we need to review all these queries or all these inclusion criteria clauses and decide whether there are any redundancies, and then we remove those, or see if there are any duplicates, and then we remove those. For query ref sets, usually there is an inclusion criteria set and an exclusion criteria set. So for both ends, the same process has to be done. And when we got to the results, we compute the results of the query that we optimize, compare it with the initial set, and hopefully it's the same. If it's not the same, this iterative process continues until we get to the right results. And just briefly how it works in real life, what you're looking at right now is a simple type ref set. Very simple. It has 11 concepts in it, each listed as a single query that queries only the concept itself. And if you go for optimizing it. After the optimization process is completed, you get to a comparison screen where you can see the new clauses that were added and those that were removed. Here, the removals are all because of redundancy. So everything that is red is removed and the new clause that was added is in green. After this optimization process was completed, we inferred that the same set of concepts could be expressed with this very simple hierarchical query expression. So that's the new definition for this query type ref set. And if you think about the effort of reviewing 11 concepts or 11 rows as clauses versus just this one, you can have a guess of how this simplifies the ref set review process. I have a few more examples here that were selected because they generate some very interesting query examples, like this one adds expressions that contain relationship refinements. So it's not always only hierarchical. You can get to relationship refinements as well. There was another example that was somehow removed. So let's just jump to the statistics. So I said we were looking at two large ref set collections from the UK. One was from the primary care domain, the other was from the clinical ref sets. The total ref set count is over 1,000. And after optimizing the definition of all these 1,000 reference sets, the clause count, so the number of queries that are listed as members, was reduced by roughly 50%. So I know it's not that linear with the review time, but since the size was cut in half, we can assume that the time that has to be spent with reviewing or upgrading or managing these sets can as well be decreased significantly. So what are the benefits of this method? One very obvious one is that it's a one-step transition from an extensional to an intentional set. You don't need to think about how you express a particular domain with a query because it gets calculated for you based on the initial starting extensional set. The ref sets are smaller and more concise in size. So it's just a smaller cognitive load just to look at them and to evaluate them and to update them or to further build additional queries that express that particular domain. And the maintenance part is something that I touched upon already, and it's something that Mark is going to talk about in more detail tomorrow. Maintenance doesn't only mean upgrades, it also means that you tend to evaluate the domain regularly to see how the modeling, how the ontology structure changed, and whether there are any things that you missed, not because of earlier versions, but because of changing in modeling and concept representation. We also run into some challenges, just as with every project. The content modeling is incomplete. I don't think it's ever going to be complete, and I don't think that's really a problem. But for some concept types, like for some administrative concepts, we don't have the option to infer very, very carefully crafted ECL expressions simply because they don't have a concept definition. So what we can achieve there is to build a set of hierarchical queries and nothing more complex. Another limitation is that the clauses that are used when building a reference set, they don't necessarily only define the members, they as well describe the cognitive process behind building that ref set. And this information is really in between the lines, but if you optimize the ref set and you remove some clauses because, for example, they seem redundant, you remove this type of information from the reference set as well. So to overcome this, I think authors or ref set maintainers should maybe start utilizing the new annotation method or something where they explicitly state why a particular clause was included, why they added some duplicates or redundancies, so that it is visible and transparent and doesn't get lost between these automated optimization processes. Some of the future work that we are scheduled for next year. Last year, I had a presentation about extending the expression constraint language to other terminologies. I was looking at LOINC and ICD-10 and local code systems at the moment, and exploring how they could be queried the same way as SNOMED city by using hierarchical constraints, by using relationship or property refinements. And since the same query mechanism is available for other terminologies, there is no reason why we couldn't use the same query type ref set mechanism for these terminologies as well, and build intentional ref sets that are not ref sets, I'm sorry, at this point, that are value sets with other terminologies, but a semantic definition is used to define them. Another optional work item for us is that ECL is very rich and it has lots of functions, and we do not utilize all of these at the moment. So when we build these queries from the extensional lists, we build hierarchical and ancestor queries, we build relationship refinements, but there are much more that could be added. ECL queries on properties, on metadata, on ref set associations, historical associations. These are not yet part of this work. And this is briefly what I wanted to say about this, and I'm happy to take questions.
Thank you, Orsolya. Well, Orsolya will now take questions. I'm sure I pronounced your name wrong 3 times. I'll call you Orsolya. So as a reminder, if you're in the room, please use microphone.
I'll start with an observation, and you can tell me if you share that observation or not. The way I've seen it is that intentional ref sets are preferred on a high-level specifications like HL7 specifications or something like that. And the closer you go to an actual implementation, which may not be a SNOMED implementation, extensional ref sets and explicit value sets are preferred, because then you have better control over the content. And also because I think ideally in an actual implementation, the need for adding something should come from the clinical side, not from the terminology side. Like something happened in SNOMED, so we should update our value sets. No, usually clinicians are the ones who should say, like, we need to express more. Like, do you share that observation?
Yes, I do share that observation, but I have an accompanying observation, and that is that as SNOMED is being implemented in countries and they reach a certain level of maturity, the amount of content that they need to maintain, especially reference sets, is it's like exploding. And in order to keep that somehow under control, they need to try to optimize some of these processes. And therefore, even though what you say is correct, and I believe that's the case everywhere where I had the opportunity to observe ref sets from close distance, I don't believe it's sustainable on the long term, and they need to switch over to query types on the longer term, or even just generate concepts on the fly without having to define a reference automatic previously.
I've got a particularly difficult question, I think, but on the slides you mentioned about that the optimized process, is that just is it a manual process, or the tool optimize, like if you give it an enumeration, it'll work out the optimal?
It's done by the tool.
All right, so it does.
So the human interaction is like you provide the ref set, you click a button, and then you get back another ref set.
And it'll algorithmically work out which is the best way. Cool. Excellent.
Anything else?
Excellent presentation. May I ask, how long does it usually take to optimize the graph sets you played with?
It depends on the size. Usually it's a couple of seconds, but for large collections to run a batch optimization, for example, for these 1,000 references for the UK, it took an hour to complete.
Okay, I have a question if you want.
Mhm.
What happens to the reference set type? Is it updated to query type as well?
Oh, yeah. Within our tool, from the very beginning, we maintain both a simple and a query type ref set together. So there is no need to change the ref set identifier concept at the point of the optimization. So it's originally stored as a query type.
Thank you.
Thank you.
Any more questions in the room? No, all right. Thank you very much. With
Thank
that,
you.
we will conclude the session. Thank you, Orshi. Online delegates, you can join another session through the event lobby. Thank you.